All right, so we have spent 2 class days and like a full week on section 2.6, and so I'm going to go through this fairly quickly and just sort of cover the main concepts, but then I do also want to take a look at a couple of the more difficult questions from the problem set in this video. So let's get to it, as the YouTubers say. So derivatives and rates of change. Generally speaking, basically, a derivative tells you the slope of the tangent line, and the slope of the tangent line tells you an instantaneous rate of change. So this thing right here is the average rate of change as a function of x from a certain point, and what you're looking for is the actual value of the slope at a single point. So in this diagram, you can see what they're saying is bring Q closer and closer to P, and you'll get closer and closer to the slope of the tangent line. And we do that using the limit, because you can never actually bring like x all the way to a, otherwise the denominator is 0. So you got to figure out a different way to evaluate this limit. And so if you take a look at this particular example here, we're finding the equation of a tangent line at y equals x squared at the point 1, 1. Well, what we're going to do is we're going to say that the slope is the limit as x approaches 1 of f of x minus f of 1 over x of minus 1. Well, f of x is x squared. F of 1, well, because your point is 1 comma 1 is obviously 1. Or you could also just put 1 in for x, and 1 squared is 1, obviously. So you get x squared minus 1 over x minus 1, which, by the way, is factorable. So you factor out x squared minus 1. You cancel out the x minus 1s. Then you're left with limit as x approaches 1 of x plus 1, which then you plug in the 1 for the x, and you get 1 plus 1, which equals 2. Okay. This is the limit definition of a derivative. It is very difficult. Well, it's not very difficult. It just takes a little bit of time. And then when it comes to writing out the equation of the tangent line, I think, did I have that written out somewhere already? I feel like I did. Where did that go? Maybe I didn't. Well, oh, there it is. There it is. It's already in your textbook. So if you want to find the equation of a tangent line at the point where x is equal to a, so at the point a comma f of a, what you're going to do is you're going to have y minus f of a equals f prime of a, the derivative function at a, times x minus a. So if we go back to what we were just looking at over here somewhere, we just found out that our slope is 2. So our derivative is 2, and our point was 1, 1. So that's right there. To be very, very clear, this is a comma f of a, which in our, I know that looks like a 9, I'm sorry, which is our point 1 comma 1. So we're going to have y minus f of 1 equals f prime of 1 times x minus 1. Well, f of 1 we already know is 1, and f prime of 1 we already know is 2, because that's what we found up here. And you can simplify it in slope-intercept form, but who really cares about that anyway? There's another definition of the slope of a tangent line where it's a slightly different way of thinking about it, and you do really want to make sure that you understand this, where you have a certain point, a comma f of a, and then you're going to say, well, a certain distance away from there, let's call it h, and over here this becomes a plus h, then is your input, and then that coordinate up there becomes, well, your x value is a plus h, right? So your y value is f of a plus h. So then the change in y is f of a plus h minus f of a, and then the change in x is h. So the slope of this line is f of a plus h minus f of a all over h. And if you're going to bring this point all the way over to here, you're going to say the limit as this thing of this thing as h goes to 0 is equal to the slope of the tangent line. And that's where this limit definition of the derivative comes from. And they give a few examples which are great and fantastic and all that and blah blah blah. But take a look at the examples. Actually, you know what? Don't look at this example because I really hate the way that they did it. Oh, that's right. In class, I totally scribbled out what they were doing in purple. Don't do that. To simplify these ones where you have h in the denominator, you just multiply the top and the bottom both by the common denominator of whatever you've got, which in this case is 3 plus h. So when I multiply this over here, the 3 plus h's cancel out, and then I get a 3. And then when I multiply here, then I just get 3 plus h, and then down there I still have 3 plus h. So I've got 3 minus 3 plus h. Distribute the negative, you get 3 minus 3, which is 0, and then you get a negative h over h times 3 plus h, and well, the h's cancel, and you get a negative 1 over 3 plus h, and then you plug in the 0, and you get negative 1/3. So that's my slope. Let's see, did they give me a point? At the point, oh boy. Well, I know it's at 3, and my function is 3 over x, so my coordinate has to be 3, comma 1. So if I write my equation of my tangent, it's, hey, look at that, y minus 1 equals negative 1/3 times x minus 3. That was my y value, that was my x value, and here's my slope. If you have any questions about that, please let me know. Couple other quick points. Velocity of a position function is the derivative, and the derivative of the velocity function is the acceleration. So if they give you a position function of a particle and they say, how fast was this going? Find the derivative at whatever time it is that they're looking for, and examples and stuff and things. And derivative, yeah, that's just different notations, which we've talked about. I don't need to go over that much. That equation, rate of change, we've talked about. All right, let's talk about a couple 3.2.6 problems. And I think probably sketching shouldn't be too bad. You basically just have to go through sort of thing by thing and sketch it out. Let's, well, 42. What's 42? I think 42. Estimate the rate of change. Oh, estimating the rate of change. The instantaneous rate of change of a function is also known as the derivative, so it's the slope of the tangent line. You're just estimating the slope of this line here. You just look at the grid. I don't know. What do you think the change in y is? What do you think the change in x is? That's the derivative at that point. Well, I mean, it's the change in y divided by the change in x. It's really late. I might have said that twice. Anyway. 47. 47's another one. Cost of producing X ounces of gold from a new gold mine. What is the meaning of the derivative? Well, that's the rate of change of the cost. So in this case, C is cost, where X is ounces of gold, so it would be cost per ounce. So it would be like dollar per ounce. What does the statement F prime of 800 equals 17 mean? Well, that means that when they are mining 800 ounces of gold from a new gold mine, the cost, the rate of change of the cost, is $17. So it's $17 per ounce. It's going up by $17 per ounce when you are producing 800 ounces. Do you think the values of f prime of x will increase or decrease in the short term? What do you think about the long term? I don't know. I mean, that's a good question. In the short term, it probably is going to go up because when you're developing new resources, you're having to put a lot of money into it. And once you sort of develop that resource and you get into like a stable operation, then your new costs kind of go away and you sort of just have to fund it on a day-by-day basis. So I would tend to say that the long-term costs would tend to go down while short-term probably goes up. Like if I were to take a look at what this looks like, it probably starts off like fairly high probably grows, and then at some point it might even drop a little bit as you're not putting more money into it, and then it'll just sort of taper off to some normal amount or something like that. I suppose the cost will always be increasing. I don't know. Just give me a reasonable answer that tells me that you thought about it, alright? Alright. I think 16 actually was maybe a challenging one. I'm just looking at the numbers. I don't actually know. Oh no, that one's an easy one. Just use Desmos. 17. I'll talk about 17 and I'm going to wrap this up. The reason why I know that this is the order is because the derivatives are the slopes of the tangent lines. So g prime of 0, well, first of all, that one's negative, and then 0 is not negative. Negative numbers are always smaller than 0, and then the rest of these are all positive because they're all uphill. And you're just going to rank these three in order for which one do you think is the steepest, because steeper slope means higher number for the slope, which means higher number for the derivative, because the derivative tells you slopes of tangent lines, also known as the instantaneous rate of change. I hope I've made myself clear about the derivative of f of x.